learn the rule. And sometimes things are not exactly like this, but we can eventually change that to something like this. For example, if you have, say, 3x plus 5x plus 9 equal to 7, now we know we can combine those, right?
Mhm.
Those called like terms. That means they have the same property. Like numbers are like terms, because number we can do arithmetic on that. And here we can also do add, subtract. So that's called like terms. So in this now we just make that into 8x, because 3 group plus 5 group, it doesn't matter what things are. They are always equal to 8 groups, right?
Yep.
Okay, so 7. And then we know how to do that to get, this is called constant. Get rid of constant, we just add this opposite. And we got 8x equal to 7 plus negative 9 is negative 2. Then we just do that on both sides. And then that's called the reciprocal. So reciprocal time, a number times reciprocal is 1. So we got x, and negative 2 over 8 is negative 1/4. Good?
Mhm.
By the way,
Got it.
are you comfortable with integers?
Oh, yeah.
Yeah,
Addition, subtraction, multiplication, division?
Yeah, it
definitely.
might, if it's like larger numbers, I might need to count on my fingers for a little bit, but yeah.
Yeah, okay, that's good. All right, so that's basically what we're doing with linear equations. And there is just one, I want to introduce you to 2 more kinds of that. You also run into this problem like this. Say 4x plus 2 equals to 3x minus 1. So how do we deal with that? We know we have to combine like terms. So basically, the way we're trying to get, remember, this is our end zone. This is our goal. We want to figure this. So eventually, we have to make things, everything on the left of the equation, that's the variable stays. Everything to the right, that's where number goes. Good?
Okay.
And to do that, so in order to move this over to this side, so what we're going to do, we do the same thing based on the same principle. We just add this opposite, which is negative 3x. And if you add something on the right, we have to exactly add something on the left, because remember, that's our fundamental 10 rules of algebra. Well, actually, it's not 10 rules of algebra. This is the rules for equations. So we have if A is equal to B, then we know A plus C equal to B plus C. So that we use that rule. So everything we do, we have to say what rule we follow. At least we implicitly is kind of in our head. That's what we did here. Now on this side, we only have negative 1 left, right?
Mhm.
And on this side, we got 4x plus negative 3x. It's the same as 4 plus negative 3. That's just 1, so it's x. And we got 2. Good?
Okay.
Now, once got here, we just
Got it.
follow what we did before. So add negative 2 on both sides. Then this side will be x, and that side is negative 3. So we find it. Good?
All right.
Okay, so I'll have you just do a couple of those. 5x plus 7 equals 2x plus, say, 1. Yeah. So you can just do kind of using a piece of paper and work on that, then we can check together. Yeah, when you are ready, let me know.
Hey, is it all right? You could walk me through how to begin doing it again?
Yep. Well, first thing we're going to remember, we have to move all the variables to the left, all the numbers to the right. Now, in order to do that, we're going to add negative 2x, the opposite of this. That way, when you add, it becomes 0. But if you add something on the right, we had add exactly the same thing on the left. So that's first step. So now what do we got? After that, we got 5x plus negative 2x is just 3x. Then we got 7 here. On the left, it's just 1. And at this point, we know how to do that. You just add negative 7 on both sides. And then what we have, we got 3x left. On the other side, negative 6. Then we just multiply the reciprocal of the coefficient. So therefore, x is equal to negative 2. That's our end.
Okay. Why do you start with the right first and then move on to the left when you add the negative number?
Because I want to gather 2x on the right. I want to get rid of the variable on the right. So that's why I did it first.
Oh, okay.
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 Now, these 2 steps, you could do the second step first, then do the first step second. That doesn't matter. Good.
Okay.
So basically what you can do is you can do the same, you can add negative 7 on both sides. You got 5x equal to 2x minus 6. You can do that. And then we just, on this side, it just add negative 2x on both sides. So 5x equal to 2x minus 6. We add negative 2x, and then what we got is 3x equal to negative 6. You can do that too. So those, the first 2 steps, you can stay, I mean, you can start either one as the first step. But the idea is to get rid of variables on the right, then get rid of numbers on the left, because eventually we're trying to get here, right?
Okay.
That's our goal. So all the variables on the left, those numbers go to the right. Make sense?
Yep.
Okay. Let me. How about you? Trying to remember your name. I'm drawing a blank here. Hello?
Yeah.
What's your name?
Jed.
Jed, yeah, Jed, right. Okay, let's do this one. 7x plus 5 equal to 5x plus 1. Okay, if you need help, let me know, okay?
All right.
So our goal is move variable to the left. I mean, and that's our strategy. Move all the variables, all the unknowns to the left and all numbers to the right. But we have to follow the rule. And the rule is if A equal to B, then A plus C has to be equal to B plus C. Very fundamental rule. Without that, we cannot do math.
Okay. I now have a -2, but what comes next after that?
The first thing, what do we do? Which one are you trying to get rid of?
Well, I'm trying to get rid of 5x, right?
Okay, so you just add negative 5x, right?
Mhm.
And then do the same thing on this side. And what do we have left?
I just have 2.
7x plus negative 5x is?
That's 2x, right?
That's 2x. Very good. Then we got 2x plus 5 equal on this side is 1. So how do we do this?
Okay, so once you get the number, you just add it to the next. That's the
Now,
sign.
second step is get rid this number, right?
Mhm.
How do we get rid that?
So you add it to its opposite, right?
Yeah, add the opposite. Then therefore what we have 2x left, right?
Mhm.
On the other side, what we have?
We have -4.
Yep, very good. We got -4. And then we need to get rid of that, which we multiply its reciprocal. Good.
Okay.
And this way use this rule. If A is equal to B, then A times C equal to B times C. Then we know reciprocal. Number times the reciprocal is always 1. So we have x here on the other side, -2. Good. Once we're here, that's the end of it.
Got it.
Good. Morgan.
Yep, I think I might have it now.
Okay. Let's try just couple. 5x plus 7 equal to say 3x plus 2. Let's see what you have.
Okay, I now have it to -5, but I can't remember what to do afterwards.
Well, what do you do first step?
Okay, so first step, you add 7 to its or not 7, 3x to its opposite.
It's
Is it
-3x, right?
right? Yes.
And after that, what you have?
Now you have 2.
2x plus 7, right?
And then you add 7 to its opposite, and that cancels it, right?
Yeah, if you negative and -7 on both sides, what we have here is 2x equal to -5, right?
Yes,
So now-
that's where I'm stuck now.
Now we have to get rid of this. Now, how do we get rid of that?
Oh, you add it to its, or you multiply it by its.
Yeah, right. We multiply its reciprocal. The reason we cannot do adding because this is a multiplication.
Okay.
And here is addition. So that's why we adding is opposite. But this is a multiplication. So we multiply because this is 2 times x. So we're going to multiply the reciprocal. And then on this side, we got x. How about the other side?
Other side.
Negative
Okay.
2.5.
Yep, -2.5 or -5/2. Good.
Okay.
Because 5 times 1, 5 times half, basically half of 5, right?
Mhm.
Just multiply the numerator. Very good. Let's just try 2 more, okay?
All right.
Mhm.
x equals 9/2, right?
I
Oh,
got 6
what you got, Jay?
to -6.
-6. Okay, let's see. And what you got, Morgan?
I think I might be wrong now, but I think I got 9/2.
Okay, well, let's check. Okay, so first thing we got rid of 3x. So what we're going to do is just add -3x on both sides. Good.
Okay.
And so what's left here is just 1x, right?
Mhm.
And x plus 3 equal to 9. Now we just add -3 on both sides. What we have,
Oh,
this
okay.
side is x, and this side 9 plus -3 is 6.
Okay.
I subtracted 9 instead of 3 from each.
Right, yeah, okay. And Morgan, where did you make the mistake?
I didn't add x plus 3. I added x plus -3. Or just 1 plus -3.
1 plus -3. So did you do the first step?
Yes.
Okay, so once you've done the first step, there is no variable on the right, right?
Mhm.
So what's left on the left is x. Good.
Okay.
So that's what we have. Okay.
Okay. Yeah, I think I
Then we
just.
just add -3 on both sides. Yeah, just need to take some practice on that. Okay, let's do a couple more, and then you'll be able to feel comfortable with it.
You add 3 plus 4, right? Once you cancel 4, then add -4 to 7, right?
Well, the first thing we cancel that, right?
Yep.
And once we're done with that, let's see. On this side is just 3x plus 4, right?
Okay, so yeah, you do add it.
Because we still have, the only thing we did is add -4x, right?
Mhm.
So the 4 still remain, and that didn't change. So only change is 7x plus -4x. We got 3x. Good.
Okay.
The other side, then 4x plus -4x, they cancel each other. So we only got 7 left.
Okay.
And
And
then,
then,
yeah, and then we just add -4 on both sides.
oh, that's what I missed. Okay.
Good.
Yep.
And then once we have that, then this side is 3 times x as variable. All the numbers we move to the right. Okay.
Okay.
And then we're going to say multiply 3x. Sorry, 1/3 on both sides. So therefore 1/3 times 3 is x, is 1, sorry. 1/3 times 3 is 1, 1 times x is x self. So we use 1, that is 1 as 1 of the 10 rules. And this side just 1.
Okay.
I got
Uh,
the same.
Oh, wonderful. Okay, let's do the last one, okay? Okay, let's see what you have.
Right. Is the answer 2/3?
Okay, let's see. And how about you, Jay?
I'm still working on it.
Okay, take your time. Yeah, just make sure you go through the process and make sure you follow the process.
Yeah, I don't know why this one is confusing me so much.
Well, so it's a, have you, I don't know, nowadays people don't use balance anymore.
I got 3.
You got 3?
I got 3.
Okay, let's see. Now, first thing we got rid of this, right?
Mhm.
So plus negative 3x, and this side plus negative 3x. So what do we have now on this side?
2.
2x. Don't forget that.
Yep.
And this line, the 9 still there. That remain. Good.
Good.
And on this side is negative 3.
Okay.
Because 3x, we take them out, right?
Oh, yeah, right.
Okay. Now we're just going to take out 9. How do we do that? We add negative 9, right?
Mhm.
On this side is negative 9. And on this side, we got 2x. How about on the right? Negative 3 plus negative 9 is?
Negative 11.
No,
Oh, wait.
close.
Wait, whoops. Okay. Negative 12.
Negative 12. Very good. And then what we do?
We add, or we multiply 2x by its reciprocal.
Which multiply the reciprocal of 2, right?
Right, yes.
That. So on this side, we got x, good?
Mhm.
On the other side,
It's 12 over 2.
yeah, which is?
Um, what do you mean?
So 12 over 2 is what? This is divisible. 12
Oh.
divided by 2.
It's 12 divided, that's 6.
Right, so it's negative 6.
Okay.
Yeah, okay.
I think I found out where I messed up.
Okay, very good.
Instead of subtracting the 3,
Mhm,
instead of adding negative 9,
mhm.
I subtracted positive
Oh, okay,
9 from negative 3.
right. So you got 6. Okay. Then that's why you got 3. Yep. Okay. That's very good. So as long as we know where we made the mistake, and that means we learned something. Good.
Yep.
Yeah, have you ever used the balance before?
A balance.
Yeah, that means old days when you're trying to weigh something, you have something kind of like a well, this is kind of old style balancing. They go the one side. Do you have this one? Have you
Oh.
seen the
Yeah, steel.
the
I've used one before.
the statue of justice?
I've seen it.
Right, statue of justice. She has a blindfold and using a balance. That means when you give judgment, you don't look at people. You just based on the evidence. So that's what using balance. Balance is a measure thing. Now, how do we keep something balanced? As long as you have, say that you have 3 things here, you got 3 things here. Now, if you keep adding the same amount on each side, is that balance still balanced?
Yep.
Yes.
Now, how about you take exactly the same thing from both sides?
You take away the exact same thing, both
Yeah,
sides?
yeah,
Yeah, it's still balanced.
some
Yeah,
balance,
this is good.
right?
I agree.
Good. So this is actually in algebra, this is what we mean by that. If A is equal to B, so if A is balanced with B, then when you add exactly the same thing on both sides, that's still balanced, right?
Mhm.
And
Yeah.
then if A is balanced with B, when you multiply something, A times C is equal to B times C. Good.
Yep.
So that's where we have that. So if you have something like this, I just give a quick example. -3. We can take this out. Now, if we take 2x out from the left, what's left on the right? We have to take out the same thing, right? If we take, which means by adding negative 2x. If we take out 2x from the right, we have to take out the same thing on the left, right?
Mhm.
Good. That way, it's still
Yeah.
balanced.
Yeah.
Do you see
Yeah,
that?
I see where you're going. Yeah, that makes sense.
So this side is 5x plus 7, and this side is -3. Good.
Yep.
Then we're going to take out negative 7 out from the left, which means we have to take 7 from the right. Good.
Mhm.
That means the still balanced. We got 5x equal to -10, right?
Yep.
Then we're going to divide by 1/5 on both sides. So 1/5 times 5 is 1. So we got x. On the other side, -10 times 1/5 is 10 divided by 5, which is -2. Good.
Yep.
So when you're solving linear equations, actually, when you're solving any equations, you basically just playing the balance act. Good. Whatever you take from one side, you have to take out from the left. Okay.
Yep.
Yeah. So next time, next week, we're going to still doing more on this. Okay. So until you
Okay.
really feel very comfortable with it. Good.
All
Got
right.
Okay. I'll see you next time.
All right. Bye.
Bye.
Good class.
So yeah.
See ya.